Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 31. Today we're going to take a break from very serious samples and we're going to actually build a video game. We're going to build the Battleship board game. I'm going to get started by demonstrating this game. Basically, the way it is played is you and your opponent have a grid. You can place ships on it. And then once all ships are placed, you can start the game, and then you have to guess your opponent's locations for their ships. And if you hit them, then they sink. And the goal of the game is to sink all of the ships of your opponents. Let's get started by placing the ships on the board. And in the real board game, you would not see the grid of your opponent, and they would not see yours. So here you can make the assumption that the opponent, which is an AI, an artificial intelligence, will not see my ships, and I will not see theirs either once the game gets started. So one thing you can also do after you've placed your ships is you can actually move them around with drag and drop. If you don't like the location, you can even shift them to vertical, move them again, so you can switch them from vertical to horizontal. So let's try to space them more out to make it more, or actually, it's okay, I'll make it a bit easier for the AI to find them. But either way, we have a ship layout in my grid now that is ready for me to battle, so I'm going to click the battle button. So as you can see, the AI placed their ships as well, so they disappeared from here. They're somewhere on the board, but I cannot see where they are. And they've already played a move, and they've been able to hit one of my ships. So let's try to hit one of their ships. And the nice thing about this being a desktop application is it's actually more user-friendly than the real game. In the real game, I have to say H6 and the opponent have to confirm if it's true or not. Here I can just click on it with the mouse, and if it's white, then it means I didn't get a hit. If it's red, then it means I got a hit. The AI played again and they got a hit. So the nice thing about this is it enables us to play a quick game. So let's keep trying to look for ships for the opponent. There we go, I just found one. Okay, it looks like it's a horizontal ship. So I'm gonna click here. There we go, I just sunk one. And as you can see, once it gets sunk, it actually lights up red on the side as well. So let's keep looking. I'm gonna try to play a full game. There we go, here's another one. Okay, it's not vertical from this side. It's not vertical from the other side. There you go. The AI just sunk my submarine. So they've actually hit more cells than I hit of theirs. In any case, let's continue playing. Okay, there we go. It's the horizontal ship. Boom. They also sunk one of mine. So, I mean, it's a fun game. And this AI is not optimal. It's not, the best AI possible. It's just a demonstration of how to build a GUI-based game. But obviously, people could, if they want, take the open source code and then add an even stronger AI and make the game even more interesting. So let's continue in any case and try to get a game over. So I'm not necessarily doing the best strategy like that, but it's usually better to distribute your hits. But let's keep trying. I'm gonna try to beat the AI. Okay, we're still about tied. 3 ships for 3 ships. Although they're not all the same size. In any case, I'm gonna keep, there you go. I just sunk one more, so one more to go. The AI beat me. So there you go, game over. You lost. As you can see, all of my ships are red. So the AI beat me at sinking all the ships first. So that's pretty much the goal of the game. I just gave you a pretty good demo of how the game is played. So let's take a look at the code now. And as you would imagine, this is a very comprehensive GUI application. It basically pieces together a whole bunch of different concepts from Glimmer DSL for SWT, like custom widgets, canvas, canvas shape DSL or shapes, as well as data binding and MVC pattern. So let's drag this to the left side and take a look at the code. So as you can see, we have a battleship class over here, and it is a custom window, meaning an app. And in the before body, it's setting up the model, which is a game model. In the after body, it's actually observing the model for the game over state. And if it is game over, and the game over was value is specified as you, meaning the player, then it says, game over, you won. Otherwise, it's the AI that won, the enemy. So it'll say game over, you lost, and it'll just pop up a message box, meaning a dialogue. And then the body of the app is just this. So if you remember one of the earliest tutorials in this series, I mentioned how in Glimmer apps, usually any GUI you build it in a way where the code is what you see is what you get, meaning this code mirrors very simply to all the widgets that are showing on the screen. So that way, no matter how complicated the GUI will get, it can always be simplified to what you see is what you get in the code itself. Meaning here, this code is going to reflect exactly what we're seeing on the screen. So let's break it down. So we have a grid layout of 2 columns. And as you can see, we have 2 columns, this column and then this column. In the first column, we loaded a grid over here as the first cell in this grid. So we loaded a grid object in the grid layout. So they're 2 different concepts, just not to be confused with each other. Grid here is more like the game grid. This is the game grid. So we loaded this first, and then we loaded the ship collection next. So as you can see, it's over here. And then the next cell is this one. So we loaded the grid of the player instead of the enemy. We started with the enemy grid and ship collection, and then now we load the player ship grid and then ship collection, and finally there's just an action panel at the bottom that has a bunch of buttons, and that's it. I mean, that is all what the GUI is, and that's the beauty of this approach. That's why I mentioned visual designers are usually not necessarily needed in building Glimmer DSL for SWT apps. You could just usually the strategy is to write the cleanest or simplest code possible to reflect the GUI, and then it makes maintaining the code very, very simple and quick. So from this point on, we can move on to dig into the various widgets. But before I go there, I'm gonna dig into the models. So for every basically visual concept in the view that you're seeing here, we have a model that reflects it. So that means we have a model grid, a grid model, sorry. We have a ship collection model, not just a view. And we have a ship as a model, and we have the grid is consisting of consists of cells, so we have a cell model as well. So in order to open all of those various files, we have to go beyond what Glimmer Sample does, which is usually just opening simple samples in a single file. So what I'm going to do is open Gladiator. It's my code editor that I built using Glimmer DSL for SWT with Ruby. So as you can see, this is the Battleship file that we were just looking at. And it lives under samples elaborate. But then if we were to look here, we have under the samples elaborate, there's a Battleship directory as well, or folder, and within it there is a model folder that hosts all the models, and there's a view folder that hosts all the view. And that's usually a good pattern of how to structure your files for an application, a real application. So let's jump into the game model next. So as you can see, it is basically listing the different battleships that a player could have. It's listing all the players that are available. There's enemy and you, and then it's got grids. It's got ship collections. It has an attribute that designates whether the game started or not. It keeps track of the current player and whether the game is over. So if we look at the grids, when they get initialized, they basically get initialized from the players list, and for every player it constructs a grid, and it's just packing them in a hash. That's why it's using reduce. but the point of it is that we have two grids. And then ship collections is the same way. For every player, we have a ship collection. And then we're resetting the started to false. Current player is the enemy at first. The enemy always starts in this game, is the way we designed it. And then enemy moves could keep enemy moves if needed. So battle is the method that is called when we click the battle button. So here, the game now is in its finished game over state, but if it was just started, and after I lay out all the ships, the battle button gets enabled. And once it's enabled, then when I press it, it'll actually route into this action or this method on the model, on the game model. So it'll basically change the started state to true. It'll place the enemy ships because the enemy is an AI. So for us, we have to have placed our ships already, but for the enemy, it'll place them randomly, and then it'll start an enemy attack. So if we were to look at enemy, let's look at place enemy ships. It's basically looping through all the ships in the enemy collection, and then picking random locations, and then setting the top left cell of each ship to some random location. So for example, if I have a ship here, the random location that gets selected might be, for example, B1. For this one, it's C2. For this one, it's C3. For this one, it's I2. And for this one, it's I6. So the way to position ships on the grid in a standard way is to always just position the top left corner of it. Whether it's horizontal or vertical, the top left corner cell is the one that matters the most in positioning a ship. So after all the enemy ships are positioned, as you saw, there was an enemy attack. Again, this is just a sample. This is the AI. This is the entirety of the AI. It's a very simplistic AI. It can obviously be improved a lot and be, extracted into its own class, and it could even do machine learning. But for now, this is just a very simple AI that has a pre-designed algorithm. The point of it is that the enemy attack should, in the end, pick a cell to attack, and then it'll attack it. That's the goal of the enemy attack. So it'll call that the generic attack method, which is used by both players. And this will actually, depending on which grid is the opponent grid or the opposite grid, it'll basically pick a cell from it, and then it'll hit it. And if it has a ship, the hit will be true. If it doesn't have a ship, the hit will be false. It basically, after that, we'll just switch player because the move has been done. And then finally, if it's the enemy playing, then they attack. But if it's us, then it doesn't attack. It just waits for us to make the next move. So that's pretty much what a game object is. The opposite grid, or maybe a better word would have been the opponent grid, is the grid of the non-current player. So as you saw earlier, it keeps track of who the current player is. The opposite grid is the grid of the other player, the non-current player. And there's the opposite player here. There's a switch player, and then there's a game over setter that will basically take a value that declares which player is the one who won, and that will set the game over state of the game. So that's pretty much it for the game. So let's dig into another concept related to the game. So let's take a look at the grid. So as you saw, it has some alphabets. It belongs to the game, to a specific game. It also belongs to a player because we have two grids, and then it consists of cell rows, like rows and rows and rows of various columns of cells. And when it's built, it'll basically use the height and width and build the cell rows with a whole bunch of cells. That's pretty much it. And it'll give each cell knowledge of what row index and column index it has or it belongs to. And then it's got a reset here method. So the reset method on here and in game is useful when the game is over and you want to reset it. So now that we finished the game, here we have a restart button, which if clicked, it'll reset the game. I'd rather not reset it right now because I want to keep showing this information, but that's what reset is about. Reset here will actually reset the started state, overstate, current player, and then it'll reset all the grids and the ship collections, etc., etc. So let's continue with cell next. So a grid consists of cells. So a cell belongs to a grid. It's got a row index and a column index. It knows whether it got hit. It knows what ship is on the cell. And if there is a ship on the cell, then the ship will have a ship index. This cell will have a ship index, meaning if I have this ship, it takes 5 cells. So that means starting from the top left corner, this is cell 0, 1, 2, 3, 4, for example. Like that could be a cell index. So it's the index of the cell within the ship. That's pretty much it. It's got a reset as well. The key thing about a cell is place ship. So you can place a ship on a cell. This is done at the beginning of the game, as you saw when I actually dragged those ships and placed them on cells. That was the place ship action. So it'll basically take this ship and place it on the cell. And the cell is always the top left corner of the ship. So here it'll do a bunch of calculations basically to figure out the other cells and to make sure that all the other cells are not occupied by a different ship or hitting the end of the grid, like the sides of the grid. So this is all checks of exceptional scenarios and whatnot. And also it ensures that when this cell gets the ship, the other cells that are needed will get the ship too. Meaning if I placed a ship over here and it's of length 5, then horizontally, then 1, 2, 3, 4, 5 cells are gonna get that ship. So that is all ensured in this model method. And that's the benefit of the model layer in general, is encoding business rules or game rules in this case for the application. So this ensures the integrity of the data. And then here we have a hit method that will hit the cell and it'll check if the ship has been sunk, and it'll switch the game to a game over if all ships have been sunk. Then finally there's just the 2S method that gives us a nice friendly representation for the cell if needed. So what is a ship? A ship, again, it has orientations like horizontal and vertical. It belongs to a ship collection. It's got a name. So name is basically one of those names: aircraft carrier, battleship, submarine, cruiser, destroyer. It's got a length. That's pretty much it. And then finally, it's got the top left cell, and this is where you set the top left cell on the ship. And here it does all the validations to make sure that it's not already occupied by another ship, or it isn't backed in a corner somewhere where the ship couldn't fit in that cell, etc., etc. So this is verifying that the ship could be placed. And finally, if it is, then it just sets the cell. Here you can change the orientation of the ship, and when you change it, it'll take care of changing the locations of all the occupied state of all the different cells related to that ship. It'll do that automatically. So again, that's been a benefit of the model layer. And also it's a benefit of how the model layer in Glimmer DSL for SWT applications are cleanly separated from the view. You can encode all of those rules here, and you can even write automated tests for them without worrying about widgets or view controls. And then here, cells will give us all the cells of the ship. It depends on an orientation. Or it'll pick the current orientation, and then it has a method that checks if all cells have been hit, meaning it's sunk. And then here you can reset a ship to restore it into its, like if I reset the game, the ship will get removed from here and get reset and placed back here. And toggle orientation is for just toggling the orientation. It just basically will flip the orientation value. So that's pretty much it. Let's move on to ship collection. So as you can see, a ship collection keeps track of all the different battleships, and then based on that, when it's initialized, it constructs all the different ships. And it monitors. It's using an observer here at the model layer. It's basically observing the ship top left cell, so that if it ever gets dragged and dropped and moved elsewhere in the initial setup of the game, it'll basically change the placed count. Actually, wait. Basically, if you place a ship period from the if you drag it from the right side to the left side, so then the number of ships that are placed is updated to this placed count. And once it hits 5, then the game becomes ready for battle. So that's the point of this, and it's got a reset action. So now that we looked at all the models, let's start taking a look at the views. So let's get started with grid. So a grid is a custom widget that represents this area, basically all of this, and it's got a label here that declares the player name. So it says you or enemy, and then after that it's got a filler label, and then the filler label is just it doesn't matter. It's just a design thing. But if we were to move forward, it's got a here it declares basically the indices with labels. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then after that it repeats for the height of the grid, and then for the width of the grid within the height, meaning for every row it'll basically create a cell, and the cell is another custom widget, and the cell takes the game that it belongs to, the player that it belongs to, the row index and column index that belong to the cell, and that's pretty much it. Oh yeah, this label, by the way, is representing the first column over here, the A, B, C, D, E, F, G, H, I, J. So that's what that is. And that's pretty much it. I mean, the code is very simple. Again, it's what you see is what you get. At every layer of the view code, the code has to remain as you see, what you see is what you get, in order to be very simple to maintain. And fortunately, Glimmer DSL for SWT helps us maintain that. So let's jump into the cell next. So again, it's a custom widget. It takes all of those options, like game, player, row index, column index, what ship belongs to the cell, type. So the type is, it can, by default, it's a grid cell, but it could be a ship collection cell. So what that means is, the nice thing about using custom widgets is that you can reuse them in various different locations of the app. So as you can see, those cells look exactly like those cells. So why not reuse the same exact widget? Well, that's exactly what we did. So cells that are included in a grid have the type grid. Cells that are included here have a type of ship, meaning they belong to a ship. So you have various types of cells. A cell is simply a canvas that is drawing some graphics. So the background color is decided by a whole bunch of factors. So as you can see here, we have cells that have a red background color. We have cells that have a blue background color, like water, representing water. We have cells that have a gray background color, representing a ship. And we have cells that are white background color, representing a ship that is removed from its place, or placed, basically a placed ship. So this is that's why this is where you could do logic in pure Ruby, and that's what's so nice again about the Glimmer DSL GUI DSL is that it is pure Ruby. Even if it's a DSL, you can mix pure Ruby code with it and very simply declare the logic. So I mean, we're saying if it's a grid, then the background color can be either a ship color or a water color. If it's not a grid, if it's a ship cell, then if it's sunk, it would get the color hit, meaning red, as you can see over here. And if it's placed, then it'll get the placed color, which is white, which is that one. And if it's not placed, it'll get the ship color, which is gray. So, and this is all encoded declaratively using unidirectional data binding in this case. So depending on how the model attributes change, the view will change automatically, so that I don't have to call the view and update it. That's why I said it's Very nice that the models are decoupled from the view, because in the model layer, I just update those attributes like sunk or top left cell, or whether there's a ship on a cell, and then the view will automatically reflect them once I declaratively wire it up to the model with data binding. So that ends up giving us the minimum amount of code needed to specify this app, as well as the highest amount of productivity and maintainability. So next, a cell is basically a rectangle that fills the canvas, and then it's got two ovals, a bigger oval with width and height of 10, or like you could think of them as the diameter, and then here a diameter of 5. So this is basically those two circles that you can see here. There's an inner circle which is filled, and there's an outer circle that is painted, not filled. So the painted one only has a foreground color. The filled one has a background color. And their colors, again, are just programmed with data binding, and the on-read converter will always get called whenever the model changes and it's reading from the model to update the views. That's why it's called on-read. On-write is the opposite. It's when you're writing to the model. So here we're only using an on-read converter. We don't need an on-write one because this is unidirectional data binding. And what we're doing is basically on-read, if it gets hit, then we'll color it a certain way. If it doesn't get hit, we'll color it a different way, etc., etc. So and that's why it ends up coloring those two circles. And the outer rectangle is just giving us, in this case, the outer rectangle is not adding that much value. Oh, actually it is. It's drawing the black rectangle around the cell. That's pretty much it. It's not doing anything else. But most of the gist of the logic is in the background of the canvas. Because this rectangle, by the way, is transparent, so it shows this background through it, because it doesn't have a background color itself. So shapes are transparent by default in Glimmer, and those ovals then give us a different foreground color depending on what's happening, whether there's a hit or whether not, or whether it's just an empty cell. Sorry. So. Sorry, a no move cell, meaning a cell that we did not make a move on yet. So finally, there's a whole bunch of listeners, like on mouse move, what happens. Like you can see the cursor here is one way, the cursor here is a different way. Here we have a crosshair, which is indicating to us that this is the area that we attack. Here the cursor is just a standard mouse pointer, so we couldn't attack in this area. So this is just logic for a whole bunch of logic for changing the cursor, as well as on mouse up. If basically on mouse up, we will do an attack if we click on a cell that belongs to the enemy. So if the player is an enemy and I click here, then basically I'm saying I'm attacking this cell. And that will simply just call the attack method that you saw earlier on the game model. And it'll handle all the logic from there. It'll do some updates on some related models, and then the views that are observing them will get updated automatically through data binding. Here there's a bit of logic for a drag and drop, on drag detected, on drag set data. So the key thing is that when we first drag a ship, on drag set data we'll read the ship name and set it in the event data, and then later we consume that event data on drop. When I drop a ship, it'll take the event data, read the ship name, and based on the ship name, it'll know which ship to place, and then it'll place the ship on that cell, and it'll update the top left corner, and it'll do all the logic that we saw the methods for in the model earlier. So, I mean, that's pretty much it. You can read this more slowly on your own to learn more about what's going on, but mostly it's changing the cursor depending on where I am and what the states are, and doing other things. Yeah, like, I mean, there's toggled orientation here. You saw that already when I started the game. I was toggling the orientation of the different ships to switch them from horizontal to vertical. So, I mean, that's pretty much it. The model handles all the heavy lifting. Here we have a model method that will it'll figure out the model from the game grid of the player, because the cell knows its own player. Here, this will just figure out which model to call the place ship method on in order to place a ship on a cell in the model of the cell, meaning the cell model, as opposed to the view, which we are in right now. And change cursor will just check different things, like if I have a ship, then I'm going to assume that we're switching the cursor to switch the orientation from horizontal to vertical. Otherwise, we're just dragging, or sorry, we're just showing an arrow because we're not dragging. So it's just different changes like that to the cursor. So I mean that's a pretty good overview of what is happening in cells in general. If we were to take a look at the ship, a ship is simply basically it is a composite. It has a grid layout, it has a ship length, and then it simply lays out cells. And basically, depending on the ship length, I can have a 5-cell ship, a 4-cell ship, a 3-cell ship, or a 2-cell ship. That's what a ship is. Next, let's take a look at ship collection. Ship collection is just a collection of all the different battleships. The list of all the battleships is in the model ship collection, and then based on that, it'll declare all the ships. And it's a row layout, meaning it's just declaring rows, various rows, and that's why we have these 5 rows. So a ship collection is this area, and it has those 5 ships. That's pretty much what it is, as far as what the ship concept is in the view. Finally, the action panel has, just has a button of battle and a button of restart. The battle button will get enabled when we've placed all the ships, meaning the placed count is updated, and once it's updated, we check if it's 5, then it'll get enabled. And then here, on click of the button, it'll begin the battle, basically. That's all it'll do. And then it'll disable the button, and then the restart will just reset the game. Very simple, very, very simple. So that's pretty much it. I think we've covered the entire game of Battleship. So to summarize, we looked at custom widgets, like the custom widget representing a grid, the custom widget representing a single cell, the custom widget representing a ship, the custom widget for a ship collection, and the custom widget that has the action panel, that has the buttons at the bottom. And then we also took a look at various models representing all the views. So we had a grid model, a cell model, a ship collection model, and then a game model representing the entire game. So the models, so we're following the MVC pattern. The models are stored in the model directory. The views are in the view. Controllers, by the way, are implicit in Glimmer DSL for SWT in general. They're basically, the controllers are, data binding basically is taking care of the control flow. By data binding the views to the models, that takes care of the control flow. That way, when I click on something, it depends actually. There are 2 different types of controllers. So if we were to take a quick look, I mean, the action panel, when you have listeners like saying on widget selected, do this, this is the controller in a sense. This is the controller of that button, is this code. So it's an implicit controller that is included in the listener. And this is, and it is proxying directly to the model, the game reset action. And you could think of the game model as playing the role of a controller in a way, but we don't really have explicit controllers. It's generally not needed. Usually these listeners are the controllers, as well as data binding takes care of control flow as well, so that you don't have to write explicit controllers. But every once in a while, it could be useful to write an explicit controller in the form of a presenter, as we've seen in other samples. But in this case, that was not needed. The models took care of all the handling of data for the view. So that's pretty much it. In order to learn more about Glimmer DSL for SWT, check out the GitHub repository.